Hey everybody, it's Coach D again, and we're on to the fourth video, part 2 of category 3 for TI Inspired Touchpad Calculator tips on released Algebra 1 star EOC questions. Category 3 deals with linear functions, but we will still incorporate what we've learned from categories 1 and 2. So if a graph of the equation y equals 9x plus 4 is translated 4 units up, which equation describes the new graph? So first of all, we need to be familiar with slope-intercept form of a linear equation. And we should know that when you change the slope, that affects steepness. And when you change the y-intercept, that causes a vertical shift up or down. And that's going to help us to eliminate answers. So we are translating, sliding, shifting up or down. This says up. So we need B to change. B is 4. If B does not change, that cannot be our answer choice. Okay? So we do want B to change, but we do not want M to change. There's nothing that describes the steepness changing. So if the steepness changes, that would be the wrong answer. So F is our answer, but let's verify this using the calculator. If we shift up and down and we don't affect steepness, we should have two parallel lines. So let's graph these two answers. The given problem and the answer choice. So I'm going to start a new document, home, 1, and no, I'm not going to save anything that I've used in the other videos. And I want a graph, which is 2. Original equation, y equals 9x plus 4. And the answer that we think is correct is y equals 9x plus 8. Oops, hold on, we have to hit tab to make the entry line appear. And we can type 9x plus 8. And we can clearly see the two lines look parallel. Now, when you just shift up or down, you're changing one of the coordinates. You're changing that y coordinate. So we can also look at a table, Control T, and we can see an arrow to the right. This first column are the y values for the given equation. The second column are the y values for the answer choice we plugged in. If they all increased by 4, then this table shows that these two lines were parallel. That was the only thing that changed. And that's what it shows, so we can move on. Okay, now what is the equation in standard form of the line that passes through the point 124 and the slope negative 0.6? So let's highlight our given information, and we specifically want the equation in standard form. Okay, well, I noticed that all the answer choices look exactly the same except for one thing, the constant term. So they're all in standard form. AX is the same for all of them. BX is the same for all of them. The equal sign is lined up, but all the constant terms are different, which means we will have different y-intercepts. The slopes are going to be the same for all of them, but the y-intercepts are going to be different. So that's all I need to do is find the y-intercept for this, the line that goes to this point and has this slope, and see which one of these has the y-intercept that matches up. So I'll start off with my slope-intercept form equation. I will label what I know, x and y and m. Then I'm going to plug into the formula. Y is 24, m is negative 0.6, x is a 1, and I don't know b. So what I need to do is figure out what b is. Well, I'm going to use a calculator. I'm going to use nsolve. Yes, this might be an easy problem, but the whole purpose is, if this was not an easy problem, how would you utilize the calculator? So I'm going to insert a new page with Control I, and I want a calculator page, 1. And I'm going to utilize the nsolve feature. So menu, 3 for algebra, one for numerical solve. And if I forget those keystrokes, I can always type in solve in open parentheses. Now I'm going to type everything I see. Do not simplify or reduce or anything. You type it exactly as is. 24 equals negative 0.6 parentheses 1 close parentheses plus b. And I'm solving for b, so I'm going to put comma b. And we should get 24.6 equals b. So I need to know which of these is going to have a b of 24.6. If you recall, when you have an equation in standard form, to get it into slope-intercept form, you have negative a divided by b x plus c divided by b. That's the shortcut. Well, all I need in all these is c divided by b. These are the c's. These coefficients of y, which are 5, are the b values. So 125 divided by 5, 77 divided by 5, 123 divided by 5, and 115 divided by 5. Now in the calculator, if I enter these as is, if they are fractions as answers, they're going to still stay as fractions. They're not going to show me a decimal. So what I'm going to do is I'm going to put a decimal point with the 5 on all of them to make sure I get decimals. So 125 divided by 0.5, oops, I'm sorry, divided by 5 with a decimal. And you get 25, okay. 77 divided by 5 with a decimal, 15.4. 123 divided by 5. That looks like our answer, but we are going to verify that this last one is incorrect. So our answer choice is H. The other thing you could have done in the calculator was you could have entered each of these answer choices and tried to actually get the equation into slope-intercept form. Now we don't really need to do it for this problem, so I'm going to actually hold off on that because wouldn't want you to do it on this one. It was too easy. We'll do that later. All right, so let's move on to the next one. What is the zero of the function graph? This is another one that's real straightforward. We can go ahead and take these 2 points, put them into the calculator, graph it, and trace our graph. So let's start off by inserting a listed spreadsheet. So Control I, 4 for listed spreadsheet. And I'm going to stack these points up. Enter the x values first, 0 and 2. And then enter the y values, 5 and negative 5. I'm going to arrow to the right, to the left, hit menu, 4 for statistics, 1 for stat calculations, and 3 for linear regression, mx plus b. Now, this has to say A with the brackets, and this has to say B with the brackets. It just says that's the column that I got this information from. So B, control open parentheses, gets my brackets. This f of 3 lets me know that the equation that's going to work for this line is going to be stored in the graph section as f of 3. So I can either tab to OK, or I can use my touchpad and just click it. So here's your slope, here's your y-intercept. Well, when I enter a graph, control insert 2 for a graph, it goes to f of 4. I hit the up arrow, that equation that was stored as f of 5 is there, and I hit enter. Now all I have to do is trace. So first thing I'm going to do is I'm going to move this label out the way, because I already know when I trace the graph, it'll list the coordinates right here. And if that's down there, it's going to be a little confusing. It's going to overlap, and it's going to be hard to make it seem. So now, menu, I want to trace, which is 5. and I'm going to do a graph trace. 1. It usually starts off at the y-intercept, and you see that point has a 0 as the x-coordinate, so that's the y-intercept. Just arrow to the right until you get to that point, and the word 0 pops up because it's a special point, and the point is 1, 0. And the 0 is the x value when y is 0. So we have a positive 1, and we can bubble it in. Let's make sure we bubble it in properly. If we had a decimal or had to round, we need to make sure we follow the instructions. Now we can see that point, but again, we're doing this for the situations that it's not an exact point. It might have been a decimal, so we need to be able to do this from the calculator also. Moving on. A student at a school will sell hats to raise money. There are some hats left over from last year, and 20 boxes of hats will be ordered this year. When the order arrives, the total number of hats the students will have can be determined by the function f of x equals 48x plus 37, where x represents the number of boxes ordered. If the number of hats per box changes so that the situation is modeled with the function h of x equals 24x plus 37, then how many fewer hats will the students have available to sell if they still order 20 boxes? It's a lot of information, and when we get word problems, we tend to skip them or get a little afraid of them. But this one is not that complicated. We noticed that the two formulas look very similar. And what's similar about them is this positive 37. It's the starting point, that y-intercept. It's letting me know that I start off with 37 hats left over from last year. The 48 changes to a 24. What does that represent? That is how many hats come in a box. X is how many boxes, and we know in both situations we have 20 boxes. Okay? So to figure out how many hats we had this first time, plug in a 20 and simplify. The second time, plug in a 20 and simplify. And to figure out how many fewer hats, we just subtract. So this is just something that we have to set it up, but we let the calculator do the arithmetic. So 48 times 20 plus 37, all of that minus, I'm going to wrap it around, 24 times 20 plus 37. So I'm going to plug all of this in the calculator. Control I for a calculator page, 1, and type what I see. Now some people prefer to do each piece separate. I think it's, to me it's a waste of energy, but if it works for you, you do what's going to help you out. So if you like to separate each piece, you can do that. Just in the end, go up and put the first value minus the second value, which is what we showed, and you'll still get the correct answer. So again, plug in a 20, subtract the difference of the first equation and the second equation. So we'll put a positive 480, bubble in your sign and your values nice and dark. Okay. Next, an airplane's altitude in feet during its descent for landing can be found using the function f of x minus 300x plus 30,000. Where x represents the horizontal distance in miles from the plane X represents the horizontal distance in miles from where the plane begins its descent. So where it starts before it starts going down. Okay, the distance from where it lands on the ground, not the distance above, the distance horizontally from where it lands. After new government regulations become law, the airplane's descent will be modeled by the function g of x equals negative 300x plus 30,500. Which statement describes this change? All right, so the airplane starts its descent from an altitude of 500 feet higher. So this is saying, do we shift up? The airplane starts a descent of an altitude 500 feet lower. Do we shift down? It descends 500 feet per horizontal mile faster or slower. These two answers are talking about the speed changing. The speed is the slope, is the rate of change. So both of them have the same slopes or rate of change. So we're not talking anything about speed. It's either the higher or the lower one. So this y-intercept starts at 30,000 and turns into 30,500, which clearly increases. That should let you know that it's higher. But to clarify that, we'll graph it just so that we can see it if we need some reassurance. So insert a graph, Control I, 2 for a graph, enter your first equation, y equals negative 300x plus 30,000. Now, there's nothing wrong if you don't see it. Our y-axis goes up to 6.67, whereas our starting point and y-intercept is 30,000. So we'll adjust that in a minute. Tab, so you get an entry field for the second equation. Y equals negative 300x plus 30,500. Now we'll zoom out so we can see those. So menu, window zoom, and we're going to go to zoom fit, which is A. Now, so that you know which line is which, because you don't necessarily know that the one stacked up top is the higher one or not, you hover on top of that line and that tells you which graph it is. So that's graph 5, which is the second one we entered. This is graph 4. So the second one we entered is above it, which is higher. Sorry about that, I had to plug in the laptop. Okay, let's move on. The graph below shows the water level in a tank below drained at a constant rate. If the rate in which the tank is drained is changed to 3 inches per hour and the initial water level stays the same, how would the time it takes to empty the tank be affected? So how would the time to empty be affected? Oops. I'll just use a line. Time it takes to empty be affected. Okay. Well, first off, we were draining it, so that lets us know we have a negative slope for this line. So to write the equation, y equals mx plus b, we have our starting point of positive 12, and we can use any 2 points. I'm going to use these 2 points. You don't have to use these 2. I'll keep it simple. I'll do what the student normally does. They normally want to use the points that they see, so we'll do that. When we go from 10 down to 4, that's a negative 6. From 1 over to 4, that's a positive 3. So negative 6 over positive 3 gives me negative 2. So there's your equation. So we could have done this without the calculator, but again, we're going to make it simple. We're going to use the calculator to show that this is what really is the slope and the y-intercept. So I'm going to insert a list and spreadsheet, Control I, 4, and stack those 2 points. You got the x values and then the y values. Arrow to the left, menu, 4 statistics, 1 stat calculation, 3 linear regression, tab, put B with the brackets, control open parentheses, and click OK. This is going to go with f of 6. So now I have the equation as y equals negative 2x plus 12, which is what we did. Now we want to change that equation to have a slope of a negative 3 because we're losing water, so the slopes are negative. But they said change it to 3 inches per hour. So they didn't say make a negative, but the fact that we're draining means you're supposed to know it's a negative. So now the new equation is y equals negative 3x plus 12. Well, to know when it's completely drained is when the y value, the height, is 0. So this is what we're looking for. And the same thing down here. So let's utilize InSolve to figure out what x is when y is 0. So I'm going to hit Control Insert. I want a calculator page. You don't have to keep entering calculator pages. You can go back to other ones. Sometimes you can use the scratch pad, but I don't really like using the scratch pad. So we'll use InSolve. And it's menu it's menu 3 for algebra, 1 for numerical solve, and you're going to type exactly what you see. 0 equals negative 2x plus 12. What are we solving for? X. So comma x. And you get 6 hours. Do the same thing, but change this to a 3. So I don't want to type all that over. I'm going to arrow up, copy it, and then go back and change that negative 2 to a negative 3. And I get 4. So to go from a 6 to a 4, I go down 2. That is 2 fewer hours. And we're done. Next one, the value of y varies directly with x. We have a direct variation. Which function represents the relationship between x and y if y equals 20 over 3 and x equals 30? Well, we have to remember when we work with linear equations, y equals mx plus b is our slope-intercept form. But when you work with a direct variation, all you need is y equals kx. That b, that y-intercept is 0, you don't need to show anything, so that k constant of variation is your slope. And then when we find our slopes for a line, m equals the change of y over the change of x. Well, for a direct variation, we have it a lot easier. We don't need to worry about the change. There's always a proportional relationship of y divided by x. So that's exactly what we'll do. To find k, that constant of variation, which is also our slope, we're going to take the y value and divide by the x value. So in the calculator, it sometimes confuses people because these fraction bars are the same length, and some people might want to put that in parentheses, but when you hit enter, it's going to turn out looking like that. So we'll say open parentheses, control divide, 20 over 3, get outside of the parentheses, divided by 30. And when you hit enter, it's going to make everything up and down anyways. So that will be 2 over 9, and our answer is G. Alright, so that's the end of Category 3, Part 2. Hope that was helpful. And we have 2 more parts, Categories 4 and 5. So I hope this again was useful. Thanks.